Okay, question 5. Given circle O, chords AB and CD are equidistant from the center. Prove that segment AB and segment CD are, prove segment AB is congruent to segment CD. Read the following paragraph proof for this problem carefully, then follow the instructions. It is given that chords segment AB and segment CD are equidistant from the center. So blank 1, it can be stated that segment OQ is perpendicular to blank and OP is perpendicular to blank. So I'm noticing that it is using that OQ and OP are, I'm just noticing that that's what they're using in the next one. And so I'm also noticing that OP and OQ, the ones that they listed, are radii. So radii means that they're congruent to each other. So for blank 1, I'm looking for something that either they're radii or they're congruent to each other. So the first one that I see is segment OP is congruent to segment OQ. That is correct because they are radii. Now OQ is perpendicular to blank. I'm looking at the picture and noticing that OQ is showing a 90-degree angle with segment CD. So that one's going to be CD, and blank 3 says OP is perpendicular to blank. So OP I'm showing is perpendicular to AB. So that's going to be the next one. So segment CD for blank 2. And for blank 3, it's going to be segment AB. Okay, because the perpendicular distance is the shortest distance between a point and segment. So then we're moving on. The definition of perpendicular lines or segments state that they form a right angle, so it can be shown the angle OPB and OQC are right angles. Then according to the definition of right triangles, triangle OPB and triangle OQC are right triangles. Since segment OC and segment OB are blank of circle C, well, what is segment OC and segment OB? Segment OC starts at the center and it hits a point on the outside. That means it's a radius. Segment OB does the same thing. That means it's a radius. So since they are radii of the circle, so that is what I'm going to be looking for blank 4 is radii. And then going back up, noticing they are blank. So the definition of radii means that they are congruent. So that's just pulling on, after we filled in the blank, our radii of a circle C, by definition, they are. Definition of radii means that they're congruent or the same. So this one would be congruent. And so the blank then justifies that triangle OPB is congruent to triangle OQC. So what did we just put together? They were talking about segment CO being congruent to segment OB. That's the hypotenuses of a right triangle. And we also previously, earlier in the in this paragraph, said that these, actually it was, yes, so these ones are radii too. So OQ and OP are congruent. So we have a hypotenuse and a leg, a hypotenuse and a leg. So for blank 6, I am looking for the hypotenuse and leg. They're because that's what we just showed that we had. So now by the blank, it can now be concluded that segment PB is congruent to segment CQ. Well, we just showed that two triangles were congruent. So bicongruent triangles is what I would be leading towards. So I'm going to see if that's an option. Perpendicular. Definition of congruent triangles. Yes, so that's how I picked up on blank 7, was I just realized that they had just stated that those two triangles were congruent. Then you conclude that corresponding segments can be congruent. When a radius or diameter is blank to a chord, it bisects that chord. So segment PB and segment, so I'm thinking to myself, okay, they were just talking about a radius or diameter is blank to a chord. So I'm looking for a radius and a diameter that they've been talking about, and they've been talking about segment OP and OQ, and I'm being what to a chord. So we have two chords, AB and CD. So these radii, notice they are marked perpendicular. So that's what I'm going to lean towards. So for blank 8, I'm looking for perpendicular. And then we're down to 1. It says, therefore, by the transitive property of congruence, segment AP is congruent to segment PB, which is congruent to segment CQ, which is congruent to segment QD. Finally, by applying the blank and the definition of congruence, it can be concluded that segment AB is congruent to segment CD. Also, if there is a relationship between what they were listing, segment AP, segment and PB, CQ, and QD, and what they listed, what they concluded. So I noticed that AP and BP or PB together combined make up the whole segment of segment AB. I'm also noticing that segment CQ and QD together combined make up the whole segment of CD. So they had to add those values together. So I'm going to be looking for the segment addition postulate right there. And that's how I would go through and use the context clues and definitions to help me answer this proof.